Does everything sound good now? I think I had my mic muted, but what is up, everybody? It is a kind of a gloomy and chilly night again here, but things are going to warm up like crazy tomorrow in southern Missouri. It's going to be like 70 here. But what is up, everybody? What is up? Welcome in. Welcome in. We got Jim, Derek, Joshua. What is up, guys? We got Derek joining the Doppler game. We got Seymour in here, guys. We already have like 20 likes. I think it took us forever last night to get to 20 likes. I think it helps when I schedule my new stream right after I finish my old one. I think that does help. But we have some stuff to talk about. Oh, boy. We probably have the most severe weather to talk about since at least July or August, probably even June. That's how long it's been since we've had this much to talk about. But we need audio. Hopefully my audio is working now. I would think it would be. Yes, everything on my end seems like it's working now. I think I just had to adjust it. But okay, so we start off with tomorrow. Here. Let me. Tomorrow, we have a marginal risk from the Southern Plains up to Kansas. And as you can see, we actually do have a really good environment in place tomorrow. I'll show you guys on the HRRR that's coming in right now. You can see here, go to Supercell Composite. Look up, this is by my house. Look at all these oranges by my house. These oranges, we have a really good environment. So this is Supercell Composite. It's basically showing you where the best combination of shear and instability is. But welcome in, everybody. Please let me know where you are watching from in the comments. Let me know where you guys tuned in from. This stream is sponsored by Brahms. Just kidding. I wish it was sponsored by Brahms. That would be awesome. Yeah, we got to get sponsored by Brahms for these Oklahoma chases. But yeah, let me know where you guys are watching from, and we'll get into this. It's a good environment, but here's the thing: it's capped. So see how this these colors right here kind of have this shading over them. That means that the cap is in place. So tomorrow's environment is pretty good, but it's capped, so storms are not going to fire off. There might be some storms later on in the evening behind the front, but they're mostly just going to be hail producing storms. So we really want to look at Wednesday is not the best either. They say slight risk from Dallas up to here. I'm not really impressed with Wednesday. I'm keeping my expectations for Wednesday low. A chase is possible. I wouldn't say a chase is likely or certain. A chase is possible Wednesday. I don't know. Anywhere from maybe southwest Missouri down to central Texas, a chase is possible. But really, I'm not very high on the setup, and I'll tell you guys why in a minute. But I want to focus more on Thursday and Friday, which are what I think the bigger days are. So here's day 4. Here's Thursday from about Woodward, Oklahoma, all the way down to southeast of Midland, Odessa. I think that this is going to be extended slightly to the west and slightly to the north. So I think you're going to see southwest Kansas get included into this slight risk here soon. And then day 5, you have a massive one from all the way from south of Dallas all the way up to Iowa. I think you're going to see this get expanded even more to the north. And I also think that you could see a 30% region come out for Friday's threat. I don't know if the 30% is coming tomorrow, but at least by day 2 or 3, I would be very shocked if there was not an enhanced risk for Friday. But let me see where you guys are watching in from. We got Illinois in here. We got North Dakota. We got Iowa, Cedar Rapids. We got Minnesota. You can't hear me. What? Can't hear me. I think we got a troll in the chat, but that's weird. But refresh YouTube. Hopefully not on my end. I think my YouTube's all good here. Southwest Oklahoma City, but welcome in, everybody. Let me know where you're tuning in from. So there's my thumbnail right there. So Thursday, that's what we're looking at for Thursday. So Here's our system coming out here. So this is the 500 millibar upper. This is a 500 millibar wind. So these are the winds about 6 miles. It might not be right actually, but somewhere like 4 to 7 miles above the atmosphere. I'm gonna have to figure out the exact. We could look it up actually. We can look it up. This is not the right thing I want to see. Shoot, this is like 3.5. This is the wind's like 3.5 miles above the surface. But I know it was a little high when I said 6, but you can see here, here's your trough out here. Here's your trough, right? Why did you change the blue? I want you on. Here we go. This is your trough right here. Here's your trough, and it's coming out to the plains. And you can see the lead edge of this kind of wave is pushing into the plains. And you're going to have a dry line set up right about here. You're going to have a dry line right about here, Texas Panhandle, far west Oklahoma into southwest Kansas. That's where your dry line is going to be. We'll look at the dew points in just a second. But you're going to have just enough flow get over the dry line, just enough to kind of pop off, I think, a couple of storms. Some people are a little iffy on if we're going to get storms. I think we're going to get storms, and you can see here, I believe this looks to me like a little short wave right here. This looks like a little short wave right here coming in to ignite. Storms probably southwest Kansas, northwest Oklahoma, Texas Panhandle, if the GFS is right. And let's see if the GFS does ignite a storm here. This is just the GFS. Yeah, like the GFS has storms right here. Has storms right there. So it does ignite storms. There is a little short wave. And then here's your low-level jet. You're going to hear me refer to the low-level jet a lot, and we can zoom in now. So this is for Thursday, guys. This is for Thursday. Here's your low-level jet. And you can see your winds here out of the south. This is about a mile above the surface. And you have very strong winds about a mile above the surface right here. And they're out of the south, but your winds up above are out of the southwest. And your winds at the surface may be out of the southeast. So what that does is that makes, well, you get winds at the surface out of this direction. Then you get winds right above at this direction, and then you get winds up here at this direction. That creates spin. So whenever you have a cloud go up, obviously that cloud gets spun into direction by different wind directions at different heights of the atmosphere, and that's your storm spin. You also have height falls. You have height falls across the warm sector, and you can see, I really think it looks like there's a little short wave right here. And we can look at some models now for this day here. See what we're going to be looking at. Whoa. Look at that model. That's going to make some runs on social media. I think I shared that picture on social media, and I bet it got some good likes. Yes, LLJ equals low-level jet. What's up, Justin? How are you doing tonight? You can see here, go through time. This is 84 hours out, so give this model some time. It's going to adjust over the next couple days, but I think this has a decent handle on the event right now. I think models have had a good handle on this event, actually. I'm very confident. You can see right about around 3 p.m., you start to see storms fire in the Texas Panhandle. And then right around 4 p.m., they start to try to route. 5 p.m., you have well-established supercells right here, east of Guyman, one west of Amarillo. Then by 6 p.m., which the model doesn't go out any farther than 6 p.m., but you really see stuff start to blossom by 6 p.m. And we can look at our enhanced helicity index, and you're going to see me reference the enhanced helicity index and I call it EHI. You're going to see me reference this a lot, but this basically tells you where the best instability and the best wind shear is kind of overlapping. So these oranges and reds, that's where the best wind shear and instability is overlapping. And you can see right here from Woodward over towards Perryton, towards Amarillo, or just to the north of Amarillo. That's where you're getting that best overlap, right where those storms are firing. So what we could, I can't take a sounding on this model, but I'll take a sounding on this model and show you guys what we could potentially see with this environment. And I want to teach you guys how to look at these soundings enough to maybe glance at them and read them. I know some of y'all are never going to understand them quite like some of us do, but you know, you're from Mount Shasta. Wow. But this is a sounding. So this is how you read one of these. Okay. Here's your surface right here. So you can see here on the left, my head should not be blocking it, but you can see 0 kilometers, 1 kilometer, 3, 6, 9 kilometers. So this graph is going up in the atmosphere. So this graph is going up in the atmosphere from the surface up. So you can see here 1 kilometer, 3 kilometers, 6 kilometers, 9, 0 kilometers, etc. Right? Your red line is your temperature line. So to the left is colder or drier, and to the right is warmer or moister. And so the green is your moisture line, and the red is your temperature line. So you can see this red line right here. That's your temperature line. Here's your moisture line. You can see your moisture line goes up. You have good moisture around 700 millibars, 850 millibars. You have good moisture. That's good for tornadoes. And then you have this little space between the red and the green line. This space right here is what I refer to as the elevated mixed layer. And it's that dry air aloft that's usually crucial to tornado development. I think at least the elevated mixed layer is. And then in between this white dash line and this red line is your cape. So you don't have a ton of cape right here. You don't have a ton of cape right here, but you have a decent bit of cape. It's not like super thick, but it's not like really, really skinny. You have about 1,500 cape probably, which is sufficient when you have this right here. Here's your hodograph. When you have this hodograph right here, and this is very complex, but anytime you see the hodograph really curve like this, that's good for tornadoes. Anytime you see it curving like that, that's good for tornadoes. But you can see here, here's your surface wind out of the southeast. Your wind's up here. Your wind's up here out of the southwest. Creates that spin. So this is a really favorable sounding. I think if this happens, I think that we will probably see a couple of good looking tornadoes. Not like legitimately good looking tornadoes, and you're probably going to see a lot of chasers out. But that's a little bit complex there, but some of you guys probably understood what I was talking about, but I hope I could help some of you guys understand a little bit more. Let's look at the other impasse model. I've been dying to look at this one. So there's this one. Here's our EHI. Look at this. Look at this environment right here. Eastern Texas Panhandle. So Perryton right here. Guymon somewhere over here. Woodward. Clarendon or somewhere down here. But that's where we're talking on Thursday. This is for Thursday. Friday could be a much bigger widespread threat. Thursday, I think, is going to be... Thursday's threat, I think, is mostly going to be confined to about right here. Maybe something down here, but your better environment is to the north. And maybe something up here, but up here you're talking about that late moisture return. So that's the one thing. You're going to have last-second moisture, but you have such a strong low-level cyclogenesis. You're going to get upper 50s up here, which is going to be enough. All you're going to need is upper 50s. But you can see here, our low-level jet is absolutely ripping 40 to 45 knots. Wow. And let's go look at everyone's favorite thing to look at, and that's the reflectivity. So this is one model, just like the other one. Don't take it for 100%, but This is what people like to look at, including myself. So here's, you can see, actually, let's look at Wednesday quick. Here's Wednesday. It's just a mess. It's just a mess of like hodgepodge. You might get a couple of supercells to try to get going in here, but it's mostly a mess right here. Yes, daylight saving times is soon too as well. That's going to be nice. Ooh, ho. Whoa there. Okay, here we go. 3 p.m. Storms start to fire 3 p.m., 4 p.m. Elevated hailers. Then that moisture comes in at 6 p.m. You see that moisture get in there. Now you have Tornadics, probably a Tornadic supercell. Tornadic supercells. This is, you probably have multiple Tornadic supercells. You have more supercells firing down there. That's quite the look. Oh boy, that's quite the look. So we're going to be favoring discrete convection. So it's another important thing is your convection going to be discrete? Is it going to be a line? And how I figure that out, I might as well show you guys how you figure out discrete convection versus linear convection, because as we all know, discrete convection, scattered convection, is going to be more conducive to tornadoes than a line, because with the line, you have everything interacting with each other. With that scattered convection, things kind of can take control of their own environment, have unimpeded inflow, etc., etc. So we'll go here to Friday. This is a perfect setup for this kind. So this is my bulk shear. So you can see all these little vectors right here are wind vectors. This tells you the wind direction. So you can see the wind is from west to east. The wind is from west to east. This is the bulk shear. The wind is from west to east. So we draw those wind lines. And now let's go find our surface boundary. Here's our surface boundary. Let's draw the surface boundary right here. So you can see your winds aloft are relatively perpendicular to the surface boundary. And when those winds aloft are perpendicular to the surface boundary, that means you have a better shot at discrete convection. You can see they're not completely perpendicular to the boundary, but really, honestly, I wouldn't be shocked if the boundary actually looked more like this anyway. So then, but even if they're not perfectly perpendicular, if they're mostly perpendicular, you're favoring discrete convection. Let's say, for example, this is not how this setup is, but let's say your boundary looked like this and your wind shear was like this. Well, you can see it's a lot more parallel to the boundary. When it's parallel, you have storms that train on top of each other. But whenever you get that flow that's perpendicular to your surface boundary, and when I say boundary, I mean cold front, dry line, etc. But if this is what your boundary looks like and your flow is like this, storms are going to be able to move off of that boundary and stay away from each other instead of colliding into each other and growing into each other. If that makes any sense right there. But anytime you get that perpendicular, and that's something we're going to talk about too with Friday's setup. I think we're going to look into Friday's setup now. Friday's setup. But what is up, Ghosty Boy in here? We got Jake in here. How's it going, everybody? We got Sam, the severe weather tracker. How's it going, everybody? If I talked to you, Colin, earlier today. Colin, if you're in here, shout out to you. But let's look at Friday, which could be the bigger day, and we'll probably come back and look at Thursday again. So here's, once again, this is the wind about 4 miles above the surface. See the trough starts coming in there. It's for Thursday, severe weather right there. Now let's move it out to Friday, and look at this sucker moving into the plains on Friday. Look at this big trough right here. You got a big trough. You almost got another trough down here. You have this big trough right here. You actually have models showing off a more closed off low up here aloft. And actually, I believe you're seeing, so negative tilt, positive tilt, more complex term. People are going to argue about this. Your trough as a whole is more of a a positive tilted trough. Here's your trough axis. It's more of a positive tilt, but there is a little bit of a negative tilt right here on this northern side of the trough. So basically, how I would explain negative and positive tilt, it's kind of hard to explain, but this trough is mostly positive tilt, but there's kind of a little bit of a negative tilt feature up here in northern Kansas and Nebraska, and that's an area that I really want to watch Friday. So here's my concern with Friday's severe weather as far as goes for, just widespread severe weather, is this trough is kind of glancing the warm sector. So do you see how this trough is moving to the northeast? It's moving to the northeast, and it's kind of, here's your warm sector is here. Your main warm sector where you could see big storms is probably right here. And at least the southern half of the warm sector, the trough is kind of like glancing over that southern half of the warm sector. The northern half is positioned a little bit better, but that trough is kind of glancing and it's kind of moving away. So that trough is moving to the northeast. It's kind of moving away from that southern half of the warm sector throughout the day. So that would concern me when it comes to getting some storms down there. Yeah, Brady. We got Stormcat 5 in here, but that would be my concern is sometimes when those troughs, I would just say it's like you punch someone in boxing and you kind of miss them, but you kind of hit them a little bit, but a glancing blow down there. But this is your dry line is going to be situated right here. I really like this region up here, northern Kansas and Nebraska. That would be my favorite region. You're going to have some kind of cold front up here, warm front, low. But I'd also watch right here if we can get enough of a kick from this trough. If this trough is not too much of a glancing blow. So if this trough was able to trend just a little bit to the east, I'd be... The euro is going to look a little different. We can look at the euro here. I think that the GFS has been a really bad model all winter long, but I really think it did a solid job last year. But the euro has a shortwave right here. You can see there's a shortwave right here on the euro, like literally right over the dry line. I bet that ignites storms on the dry line. But once again with the euro, you can see this negative tilt to this trough. Now the whole trough is positively tilted, but at least this portion up here is negatively tilted. So that's when, if you draw an axis in the middle of the trough, and if it's pointing to the southwest, your trough is positively tilted, and if it's pointing to the southeast, your trough is negatively tilted. This one has some aspects. This trough up here, I mean, honestly, like this shortwave right here is the main shortwave that's causing severe weather, and this one's more negative tilt. So that's going to ramp it up a little bit. It's like if someone is kicking it's like if you're kicking a soccer ball. If you're swooping from below, your soccer ball is going to have a little bit more lift to it than if you're just kind of like going from above and then you're like if you're swooping down with your foot, your soccer ball is going to get more lift to it. That's how I would describe negative versus positive tilt. You usually get a little bit more lift and defluence with a negatively tilted trough, but there have been big outbreaks with a positively tilted one. Here's the big difference I see with the GFS and the Euro. Here's the low-level jet. The Euro has a pretty solid low-level jet from eastern Oklahoma up to southern Nebraska, but nothing that impressive. I mean, these are 35, 40 knot winds right here, so nothing too impressive, about 40 miles an hour right above the surface. Like, not bad, but for this time of year, not great. But here's the GFS. Look at the GFS. My goodness. The GFS has 45. 50 knot low-level jet, and that low-level jet is way more expansive. Look at the difference right here between the GFS and the Euro. I mean, I'll get another window up here, and we can see that very clearly here, the difference between these models. Here's the Euro low-level jet. There's the GFS. GFS, Euro. Look at the difference. That's a big difference. So I actually think the Euro looks a little bit better with its mid-level trough, so I'm a little bit confused on why the GFS has such a stronger low-level response. It's very, very interesting. Um, very, very interesting that there's that difference there. But we can take some soundings. There's your dry light. You can see here's our EHI. This is your best combination of shear and cape. And really, the best of that is about right here. It's about right there. So if we can get our trough to, if the trough is a glancing blow down here, it could be interesting, but it definitely looks like a direct hit up here. I have overcome my sicknesses a little bit. I don't know if you guys can tell. I'm probably talking a lot clearer today. Let's just take a sounding up here in Nebraska. See what we are working with here. This is a beautiful sounding right here. A little bit low on the moisture side of things, but you can see a really nice EML. Would want to see a little bit more moisture down here. But you can see this hodograph right here. There's your curve. There's your curve right there. And then up here, your hodograph goes up like this. And that's what we call veer back veer. So you get your hodograph to loop in the low levels. And then when it starts going up like that, that's what I would call veer back veer. And that helps vent the precipitation away from the updraft, which means you're going to have a higher shot at getting a very photogenic tornado because those winds in the upper levels are making that precipitation go to the north of the storm rather than falling right on top of the updraft where your tornado would be. I would think that our hodographs are going to look somewhat similar down there in Kansas, maybe even more of a potent low-level curve, and then, yep, they swoop up like that. Once again, a lot of dry air. So that could be an issue. Lots of dry air in the mid-levels. Sometimes when you get a lot of dry air in the mid-levels of the atmosphere, it can choke your storm off. Your storm can get too skinny. It can get too much dry air entrainment is what we call it, and the storm gets choked off. Let's take a sounding down here on the border. A little bit down into Oklahoma. Little bit better moisture there in the low levels with still a pretty big EML up here. But same shape. The hodographs are very similar. You get that curve and then it just goes up. So these hodographs are classic dryline hodographs. And they remind me of a setup a couple of years ago, April 26, 2024. I don't know. There's a big tornado outbreak up in Nebraska and Iowa. I don't know what the hodographs looked like up there, but at least the hodographs in southeast Kansas and the environment in southeast Kansas, this is a very similar environment, and especially wind shear environment here as it was down on the dry line in southeast Kansas, northeast Oklahoma on April 26, 2024. And there were several photogenic tornadoes down in southeast Kansas that day. I unfortunately was down by Veneta, Oklahoma, and missed everything. Cat bust. But it almost went. It was this close to going. It almost went. Dew point. Yeah, y'all want to see the dew point map? Yeah, this is a beautiful dew point map. This dew point map could get me going. I'll tell you that, Brady. But look at this. Look at this surface low right here. This is beautiful. I'm going to zoom in and let's actually break down this map. Wow, look at that. This is gorgeous right here. If this is right, we could be in for a good day. But yeah, your surface low your surface low is kind of right here. You don't have a really defined surface low, but here's your cold front. Here, there's your cold front. You can see here winds are out of the north. To the north of this cold front. Rich moisture. Here's your 60-degree dew point line right here. There's your 60-degree dew point line. You have upper 50s up here in Nebraska and northern Kansas, which is plenty for this time of year. With this kind of system, this kind of trough, that's plenty. You have your really dry air coming out of the southwest right here, meeting that warm, moist air from the southeast. So there's your dry line. So here's your cold front. You know what? I'll draw the dry line. We could draw the dry line in yellow. There's your dry line, cold front up here. Here's your triple point, dry line, cold front, surface low up here into Nebraska. This would be a very intriguing spot right here. You also have to watch for any dry line bulges. Anytime your dry line bulges out just a little bit, that's a spot that you have to watch. You have to watch those dry line bulges. You also have to watch where there's increased convergence on the dry line. So anytime your dry line, this dry line doesn't bulge out, but let's say that this dry line looked like this and it bulged out right here. Well, right on the bulge, you'd have increased surface convergence, and that's where you could sometimes get a storm. So we have to watch, and this is a global model. This is a global model that won't indicate if you have a dry line bulge or not, but we'll have to watch that. Yeah, you got to watch out for the bulges. Yeah, but look at this, deep moisture, mid 60 dew points, plenty of moisture, big time low level jet. I wonder why the euro is so much. Why is the euro not quite as bullish here? Here's your euro low level jet. It's pretty good. I mean, it's good, but it's just not quite as bullish. Look at the GFS. It's ripping, especially out here and out to the east. But even this 850 millibar, these 850 millibar winds are literally banked. This is your dry line is right here. Your winds are banked right up against the dry line. Sometimes you see those winds displaced a little bit to the east of the dry line, but they are banked up right against the dry line this time. And so I don't know why. Let's see. I want to look at some other models and see. Here's the Canadian. So the Canadian looks like a pretty lame chase day right here, but the Canadian's more in agreement with the euro. The icon kind of in between the euro and the GFS, and then the UK Met, like anybody even cares about this model. It's all wacky. So some of these models, and this is why some of these models are wacky. Okay, there's a big difference here. I want to show you guys this. Big time differences here. So here's our 500 millibar map. And look at this kind of like negatively tilted trough right here on the euro. If I go to the UK Met, looks totally different. Look at how the trough is more flattened. The trough isn't like bunching up like this. It's more flat like this. See that? These winds are more flat. They're not like curling in. They're not curling. It's not getting that negatively tilted punch. It's not curling in. So that's why this model and this model, I bet this model is going to look the same. Yeah, look at this. This is gross. This is ugly. Look at your winds. They're like this. There's a little bit of curl right there, but they're mostly just like this. If I go to your euro, the European, the GFS shows the same thing. Look at how you have this negatively tilted trough right here, and your winds are like curling up like this. Look at how much more defluence there is on the euro. That's a big difference. That is a big difference. So while the euro and the GFS actually seem to agree on the pattern a little bit, there are still some big discrepancies with some of the other models, but I'm going to go ahead and throw those out mostly and focus on these ones. Here's your European. Here's your euro sounding. So even like we don't have as strong of a low level jet, it's still really good, arguably even better. I mean, look at this. A lot of dry air. That's something that I want to be weary of. Lots of dry air. Like I said, sometimes that abundance of dry air chokes those storms off. But look at this. You got your curved totograph, and then look at that veer back veer. The precipitation is gonna get vented away from the updraft there. But beautiful sound all the way down here, even south of Wichita. Beautiful soundings here, just more moisture down here. So all the way up, your warm sector goes all the way up to the Minnesota border there. So that's Thursday and Friday. So I'll tell you guys my general expectation here for both of these days as of right now. But here, we'll go So this is where I generally think, this is where I think Thursday is going to be. It's anywhere right here. Eastern Texas Panhandle, southwestern Kansas, northwestern Oklahoma, right here. I'm expecting multiple supercells, and if those supercells root to the surface, they will become tornadic because the environment is very conducive for photogenic tornadoes. I wouldn't be surprised if there are several photogenic tornadoes, even a couple of stronger tornadoes, given the looping in the low-level photographs and the favorable moisture below 700 to 600 millibars. I'm I really like Thursday a lot. I really like Thursday. I've been telling people this. I really like Thursday's setup, at least from a storm chasing perspective. Now, these storms are going to be moving pretty quickly, but nothing too crazy. But that's Thursday. I really like Thursday. That's a day you're going to want to tune into. Friday, you have a bigger warm sector. And this is the area I'm watching. So kind of central Oklahoma up to kind of right here. This is the area I'm watching Friday. So from central Oklahoma up to far western Missouri, central and eastern Kansas, up to central and eastern Nebraska, and even I think parts of Iowa. I think that warm sector is going to be pretty expansive. So we have to see exactly this little egg that I drew right here. This egg could shift a little east. It could shift a little west. But that's the general area I'm watching on Friday. My expectation here is I think that you have a chance for a few really nice tornadic supercells to fire off in this area on the dry line. I really do believe that Friday has all the makings of a really good tornado outbreak for March. Like nothing crazy that you'd see in like April or May, but like for March standards, I think you have a shot at getting a very solid tornado outbreak in the plains, which has not been a common area to see severe weather in March. So our recent March outbreaks have been more in the Ohio River Valley or the Midwest, or they've been down here in Dixie Alley or the Mississippi River Delta. But we haven't seen a lot of action in March in the plains, so it's about time that it returns. And I think it will Thursday and Friday. Of course, this stuff can change, and there's always caveats. Like I said, the biggest caveat for this day is that maybe there's just a glancing blow down here. A glancing blow, because you have your trough that's moving north and it's moving away. But if it can move just enough to the northeast, I think you'll get some storms to fire off down here. And I bet the Euro probably does show that. We can go look at that. That's the GFS. The GFS does not. Here's the other thing. GFS does not really show much precipitation on the dry line. That's it. There's not a huge signal for precipitation. That's something to also watch. Here's the Euro. It also doesn't show. This is kind of worrisome, actually. Maybe I'm a little less confident. I don't know. I don't know why there's no precipitation being shown on the dry line right there. It's very odd. I don't know if I quite believe that. You have some up here on the cold front, snowstorm on the backside, and then you have some out here that we'd have to watch. But there's not much precipitation being shown on the dry line. Very odd. I feel like the 12Z had some stuff. Here's the 12Z. Yeah, look at the 12Z. The 12Z, you had supercells on the dry line up here and up here. So that would be my concern for Friday, and I wonder if that dry earth. So that's my concern for Friday. Glancing blow of the trough, and potentially too much dry air. When you have too much dry air is good. It gives your storms a little bit extra instability, and it can give your storms the opportunity for more photogenic tornadoes. But too much dry air, your storms are going to choke themselves out unless they really have big time forcing. You can see some supercells up here too as well. Let's look at ensembles. So ensembles is kind of the combination of everything. Let's see if they're throwing out precipitation. Okay, we don't want to look at that. Let's look at this. The ensembles are not too keen on much precipitation out here. They're locked in here on eastern Oklahoma. I think you're just going to have morning convection. Some of this might not all be elevated. This could turn into non-elevated convection down here, but let's look at the 18. There's some signal. There's a little bit of signal, but not much signal up here on the dry line. Most of your signals down there in East Oklahoma. Let's look at the GFS. Same thing. GFS is there's not a ton of signal for precip on the dry line, but I've seen this before. Usually it's not 100% correct, but this is maybe something to watch. So maybe the environment is going to be very widespread on Friday, but maybe your storms won't be, but we just have to watch. These are just global models. They have some problems. They have some issues, but we'll have to see. Let's look at another impasse cam. I think this one will go out all the way. Yes. So I want to go back over some of those for Thursday. And then we're going to touch on next week. What's up, Jesse? How's it going? Beatrice, Nebraska will get in on the action. I think it's possible. Good old Beat Rice, Nebraska. Is that what you call it? Beatrice. I was dry. Yes. There's a huge precipitation. This impasse model at 6 p.m. is starting to show some stuff firing down here Thursday, but it's not as bullish as the other ones. I don't even want to look at the Rufus. I hate this model, the Doofus. I don't like to use the word hate, but this model, I don't like it. And it does show a bunch of supercells firing right here. So right in line with some of the other ones. This model is going to show something crazy for Friday, and I just know people are going to be sharing it all over Twitter and Facebook tomorrow. Everyone's going to be like, oh my gosh, mega outbreak is coming on Friday, and it could be a good outbreak. But I just know. Jim, yeah, what is up? Pumpkin, how's it going? Chef Andy, Seymour, what is up, everybody? Please smash that like button, guys. Let me know where you're watching from, and let me know. You guys want me to... I'm going to break down the pattern after this week, which gets very complicated, and I'll show you guys why the pattern gets so complicated after this week. Let's go into the future. Here we are once again. So here's what happens. So here's your system Friday. Okay, so here's your system Friday. Like I said, you kind of have, this is one big part of the jet stream, but you also have two separate troughs. You kind of have one trough right here, and you have another trough back here. Oh my gosh, there's too many lines on the... Yeah, you have one kind of wave of energy back here. You have another up here. And this wave of energy back here is going to go down here. It's going to dig down to the Baja of Mexico, and it's going to sit. That's what we call a cutoff low. So that cutoff low is going to sit down there by the Baja of Mexico. And the question is, how fast does that cutoff low eject out to the United States, and how long does it sit down there? That's the question. So here we are. This is Friday. And you can see as that main low moves off, here's our cutoff low. Look at that. Look at that big cutoff low. I wonder if this is going to pump a lot of moisture into northern Mexico, southern Arizona, southern New Mexico. You guys probably need the rain, but this is probably going to be pumping moisture into some of these spots. Jesse, I know you're in Las Vegas. Are you too far removed from this? But here's your cutoff low. It kind of just sits here for 2 days. Look at this. This is Saturday. Here's Sunday. It's still sitting down there. Here's Monday. It's still sitting down there. And then Tuesday, you have this big wave of energy up here in the northern Rockies, and it starts to kind of conjoin with this other wave of energy, and you're going to have multiple days of moisture return. You're going to have a huge warm sector across the United States. So how does this trough eject is going to be key. So if this happens right here, you're going to have some iffy severe weather setups, but you're definitely going to have some ingredients in place if this is how it does right here. But I'll show you guys the difference here. This is the 18Z GFS on Tuesday evening. Here's the 18Z GFS Tuesday evening. let's look at the 12Z. Let's go see the difference here, because it's going to be very, very, very different. Here's 12Z Tuesday. I said Tuesday evening. Yes. So here's the newest GFS. Look at this. Your trough is all the way back here still over Mexico, and it's digging into southern Texas. But you go to the other one, now your trough is all the way over here in Kansas and Oklahoma. That's a big, big difference, and you're having a severe weather outbreak right here ahead of it. So how long does that trough sit there? I think if it ejects a little bit earlier, I think that's really maybe going to – I think if the trough can eject ahead of this bigger wave, it's really going to favor a more robust severe threat in this area. But if that trough maybe waits down there a little bit longer, that second wave of energy could really kind of affect its ejection. But maybe, I don't know, maybe they could kind of, maybe the troughs could kind of merge together, and that could be more robust. I don't know. But yeah, we'll see. Let's see what the euro does. I don't even think the 18Z euro doesn't even go that far out. But you can see Sunday, that cutoff low is sitting down here, and it ain't moving. I mean, the euro only goes out 150 hours or so, but that cutoff low, it ain't moving. So it's sitting down there. It's actually retrograding back to the southwest. By Sunday afternoon, it's retrograding back. You can see this big wave of energy coming in over the Cascades. I bet you're going to get smoked with some snow up there. I do wonder, do you guys does the southwest U.S. get a lot of rain? One of the big things for severe weather out in the plains is dependent on how dry the southwest is, because that's where elevated mixed layer. I was talking about that elevated mixed layer. That's where that air comes from, is from the Four Corners region. So if the Four Corners region is abnormally dry, sometimes that elevated mixed layer gets over the Rockies and it's a little bit too dry. Oh yeah, you guys do get some rain, nothing crazy down there. Rocky Mountains finally getting some more, but look at this, right? This area right here is so dry all winter. So you guys really are going to be benefiting from this rain. So another risk, I haven't even talked about the flood risk, but we can look at we'll look at the 12Z euro, because that will actually go out to 360 hours. So let's play this forward here. So here's our first trough coming in. There's that second trough. You can see by Sunday morning, it's retrograding still to the southwest. And then finally Monday, it takes all the way until Monday, it starts to finally eject. But it ejects a little bit late, and I feel like when it merges with this trough, it's not overly favorable, and you're not going to have a favorable severe threat. Like, you're going to have a severe threat out here around the 10th, 11th time frame, but this is not favorable. So if that trough ejects a little earlier, so if that trough ejects about right here, if by Sunday afternoon that trough is over here and it's ejecting, you're probably going to get a much bigger threat than if it waits until really Tuesday. So if it ejects Sunday, Monday, you're probably going to get a bigger threat than if it ejects Tuesday. Even then, I still think it shows a big severe weather threat. Yeah, even then, look, your trough ejects on Tuesday. And this is kind of insane right here. This is more insane than any other sounding we've even seen tonight. So even then, I mean, honestly, even with your ugly, slow trough ejection, you still have a huge warm sector with a huge severe weather threat. But see what I was talking about? Look at how big this warm sector, and when I say warm sector, I mean like where your moisture is. Look at this. This is huge. You got 60-degree dew points up to southern Wisconsin. You got from West Texas to southern Wisconsin, you got those 60-degree dew points all the way out to the Carolinas. And I think they get up into Michigan. Look at that. You get 60-degree dew points up into Michigan Tuesday evening. I mean, that's pretty substantial right there. So even with that slower trough ejection, you still have a pretty substantial severe weather risk. And then the next day, you can see everything kind of crashes. This is pretty ugly, but you're probably going to have a pretty severe squall line right here with all this crashing. But so that's what we need to watch. How that cutoff low How long does it sit there? How quickly does it eject? You need snow in the Cascades. So, Jim, answer me this question. Has the Cascades, have they been short on precipitation or just snow? Because I thought maybe I saw something where they had gotten a lot of precipitation this winter, but just not enough snow. You're going to get a little bit of snow in the Cascades, mostly rain, though, Wednesday. And then more waves of energy. Here's your big waves of energy later into the next week. You get, but mostly the Oregon doesn't get anything. It's mostly, up by Northern Cascades into British Columbia. So cold air is going to return as well, I think, mid-month. There's your cold, a little bit of a quick cold shot, and then everybody warms up decently again. Yeah, daylight savings. Ben, if you would like, you can mention any times or updates or revising of the models you have there. Yeah, the new models kind of come in. They come in a couple hours, then the next 2 or 3 hours. So I won't be live at that point. But tomorrow, whenever I go live again, we'll have a lot more stuff to sift through here. So anything you guys want me to talk about here before I wrap this one up? Let's look at the NAM. I don't like the NAM, but let's look at it just for fun. It's really good. It's a really good look for Thursday on the NAM. It's a really good look for Thursday on the NAM. My only other worry for Thursday, I told you guys I really like Thursday, which is true. I really do like Thursday. My only other worry is if this trough is just slightly late. Like, I think it's getting there right in time, but if this trough is just slightly late, that could be a little bit of a concern. Maybe the forcing is just a little bit too late. I would watch it. Yeah, we were looking at the SPC outlooks earlier. So here's your SPC outlook. So here's Tuesday. Like I said, this is kind of just a marginal risk wind and hail right here. We go to Wednesday, very marginal risk. I mean, they have a slight risk out. I don't think there's much of a risk, but you could see some damaging winds, some hail. The tornado risk is very, very low. I'm anticipating probably a 2% tornado risk on Wednesday. Like I said, there's a possible chase Wednesday, but I don't really know if it's too likely. Thursday. Here's their risk for Thursday. I think they're going to move this slightly north. I wouldn't be shocked if this is a 30%. Maybe not with tonight's update, maybe by the middle of the day tomorrow or by tomorrow night. I would not be surprised if there's a little bit of a 30% somewhere on this one. Here's Friday. Here's your big risk. I think this is going to be moved north and west. I also think this is probably going to become a 30%, but like I said, there's some things holding it back that we need to really watch. And I think if you do get a 30% Friday, I think it's going to be more this area right here. Saturday, there's also a risk on Saturday. I totally skipped over this earlier. I think there's another risk up here Saturday, up by the Ohio River, Indiana, Ohio, into Pennsylvania, West Virginia, and then there's a risk down here. Kind of lower end stuff. I mean, you're going to get some damaging winds. You might get a couple of brief tornadoes, but very lower end. I know Garrett has his Discovery interviews in Ponca City somewhere Saturday, so if we're out Saturday, I'll probably be solo because he has some interviews. But hey, Pumpkin, thank you so much for tuning in. I appreciate it. So that's kind of how it is. Overall, you could have some severe weather Sunday and Monday. I know we didn't touch on that much, but it's so hard to see outside of a week because of the variability. But you could have some severe weather Sunday down in South Central Texas. It doesn't look like anything great right now. It usually never is down there. And then Monday, you start to get this stuff back into the plains. into the Ohio Valley. But we just need to see how this second trough ejects before we even get into any of that stuff right there. But, well, I don't know how long I've been live. How long have I been live? Oh, I've been live for almost an hour now. All right, so we're about to hit the hour mark. Guys, let me know in the comments. Let me know stuff I can do better, stuff I need to do more of. What did I do well? I want to improve these briefings, and I don't like I want to break down the weather for you guys, but I also don't want it to be too complex to where people can't understand it. But I also don't want to be too simplified, because then I can't go through my full breakdown if I'm being too simplified. And you kind of get to see into my brain a little bit what I'm thinking about this stuff. But I think on that note, if we don't have anything else, I think I'm going to go ahead and shut this one down for the night. I appreciate you guys. I will be live again tomorrow at some point. I have no idea when that's going to be, but just look for my live stream tomorrow. I'll probably schedule it tonight or tomorrow morning. And I will see you guys next time. Good night, everybody. Get some good sleep. And I am excited for the upcoming chases this week. Let's go. Let's go. Let's go. Let's go.